This is obviously a Databricks event. So I don't know if you were tracking Databricks news, but Databricks acquired a company, Mosaic, that was leading machine learning research and LLM research. It was big news, and it really was a notable acquisition because it allowed Databricks to round out their investment in machine learning, which has been significant. They have a big investment in ML flow and model serving endpoints, and a lot of ML products that are machine learning adjacent. So if you haven't seen the full suite of what Databricks is doing there, it's worth checking out. A lot of people know Databricks for data pipelining and Unity Catalog and data warehousing and the data lakehouse and the medallion architecture. They're well known for that, but the ML stuff is really, really worthwhile and something that I've worked with a lot and worth checking out. So we're very, very lucky to have our speaker today. And I don't know.
I'll do this intro. Yeah. So big welcome. We'll turn it over to Vitaliy Chiley, who is the head of NLP Pretraining. There we go. I practice this, I promise you. So we're gonna let him take over. I'd say feel free to kind of ask questions as we're going. And I gave him some guidance that as we get later, maybe just say, all right, we'll talk at the end and we'll get you all through this. Planning to officially be done by 7:30 with a little bit of time to chat afterwards. We'll do our best. Either way, thank you for your patience. Let's do this. Go for it,
man. So as Dustin said, my name is Vitaliy, and I'm going to be talking about DBRX. He said that officially this is over around 7:30, but I haven't actually practiced for length that much, so I have no clue how long this is going to take. I'm going to keep you here all night. To get a little bit of a pulse before we dive in, who here knows maybe what a transformer network is? Okay, so a few of you. Does anybody know what or keep your hands raised. Do you know what an LLM is? Okay, therefore, so I'm guessing that most of you know what something like a GPT is, and therefore what ChatGPT is. And so what DBRX is well, the ChatGPT, the core product, is a transformer style network. And what DBRX is also a transformer style network, where the performance of DBRX on some academic benchmarks is actually better than the original ChatGPT model that was released under ChatGPT. So it's better than GPT 3.5. It's not quite as good as OpenAI's flagship model, but that's kind of an intro into what DBRX is. So the agenda for today is I'm going to talk a little bit about introduce DBRX. I'll talk a little bit about the architecture, and then I'll talk about how the model does in the real world when we compare it to other models. I'll also talk a little bit about training and inference efficiency and why we made some of the architecture choices that we made based on wanting better training and inference efficiency. And then we'll give a short summary and open it up to questions, or maybe a slightly more formal setting of questions. But as Dustin said, if you guys have questions, feel free to ask. Also, am I talking loud enough? People in the, okay. Seems like a yes, maybe. Cool. So what is what is DBRX? You're good? Maybe a little louder? Okay. I will try to project. We'll see what happens. So DBRX is Databricks' very own open source LLM. We open sourced 2 versions of the model. We open sourced the base model that we pre-trained, and we also open source a model that we instruction fine-tuned on instruction fine-tuning data. As a quick comparison, so Llama 2 is a transformer network released by Meta, and it's a 70 billion parameter network. And you can see how some of the architecture choices that we made with DBRX allows DBRX to, even though it is a much bigger model, you can see that it produces text. It's producing text at a rate that's almost twice as fast as a model that's half the size. So that's DBRX. DBRX outperforms established open source models, such as the Llama 2 model from Meta, the Mistral model from Mistral, and the Grok model from X, from like X.ai, so from Twitter, on benchmarks that try to capture the idea of language understanding, programming, and mathematics. DBRX also outperforms GPT 3.5, which is the like core technology under that like powered ChatGPT, on these same benchmarks of language understanding, programming, and mathematics. And so in total, you can kind of see that DBRX, it is open source, which means that like any company can go and use it. It also means that if Databricks or if your organization ends up using DBRX through Databricks, and then Databricks for some reason goes under, which I hope it doesn't. But if that happens, you still have access to the model because it is in the open source space, and you can download it and use it wherever you want. That said, the Gen AI space does move fast. And so maybe a month after we released DBRX, Meta released Llama 3 after releasing Llama 2. And Llama 3 does, their 70 billion parameter network does do better than DBRX. And so the space moves fast. And so what you got to recognize is that when I say that Llama 3 does better than DBRX, what I'm saying is that on academic benchmarks, DBRX is now not the best open source model. Llama 3 is the best open source model. But where it matters, what we believe is that for enterprises to be successful in the AI space, they need to customize their own models on their own data and deploy it for their own specific use cases. Because we can, show you academic benchmarks, but fundamentally, like, do you care about academic benchmarks? No, you care about deploying products. And I think like a really good showcase of this was effectively like Google I/O 3 days ago. I love that they did this like 3 days before this talk. They showed how they're deploying their version of this, Gemini, across as like an aid to all the Google Suite tools. And something that they did not do in the presentation is they did not show any academic benchmarks, like at all. All they showed is this is how good it is at augmenting the user on Google Suite product XYZ. And so fundamentally, if a company is going to be successful in the AI space, it needs to train their own models on their data for their use cases, and not necessarily for that. And so in this talk, I'm going to kind of go over the tooling and the techniques that we use to train DBRX. And these tools are all kind of available through Databricks for our customers to train their own models on their own data. Databricks already kind of warehouses a lot of data, and so it's kind of the perfect place to train models for customer use cases. So let's start with the architecture. So DBRX is a transformer-based decoder-only language model, and it's trained using next token prediction. It is trained on entirely publicly available online data sources. So yeah, we did not use any customer data to train DBRX. We just trained it on online data sources. I think in the last slide, I kind of alluded to the fact that academic benchmarks don't matter for enterprise use cases necessarily, or for the use cases that our customers want to solve and deploy to their customers. At the same time, to showcase the technology, the academic benchmarks is kind of all we have. So I will be talking a lot about academic benchmarks, and using random online data or publicly available data sources is kind of perfect for that. The DBRX model was trained on 3,000 NVIDIA H100 GPUs. And that includes the pre-training, the after-training instruction fine-tuning, and the RLHFing, the model evaluation, the red teaming, and refining of the model. We did that all over the course of about 3 months using about 3,000 GPUs. Something that we do really want to emphasize is the fact that high quality data is probably one of the most important things in this. Working in the machine learning space, if you give me data, I can fit a model to that data. If you give me trash data, I will produce you a trash model. And so the quality of the data and that's really what matters a lot. And so, yeah, we trained the model on 12 trillion tokens, and we trained it for a maximum sequence length of 32,000 tokens. And in general, we think that we estimate that our training from the previous version of the model, so the Mosaic org released MPT previously, and MPT, we think that our training has improved a lot since then, and I'll talk about that a little bit more later.
I have a question. Well, what does high quality data mean? Is it
Sure.
Yeah, can you define that more?
So when I say we trained on the just text from the internet, all open source data sets, we try to avoid things like 4chan. It's a good, first step is avoid 4chan. And then there's also Reddit chats can be kind of all over the place. Very often people say that GPTs or whatever, they're trained on all of Reddit chats. Realistically, training on Reddit chat is kind of a bad idea. And so high quality is if you can get, publisher edited books, that's relatively high quality. Most of that is hidden behind massive paywalls that we just won't have access to. But you try to get things that you hope have editors and are not just someone ranting on the internet. Yeah. And then we do a lot of filtering to where we try to do some data science to, kind of point to good data sources and then cluster all of our data. And then anything that ends up in the clusters anywhere near the good data sources, we say that that's higher quality than the stuff that's further away.
Yeah, got it.
Thanks. Yeah. Cool. So talking about the architecture, DBRX is an MOE based transformer model. And so it's a fine-grained sparse mixture of experts. The model has 32 billion parameters, but given the fact that it's sparse, only 36 billion parameters are used. Sorry, I said 32. Sorry, I'm going to restart that. The model has a total of 132 billion parameters, but the sparse architecture means that only 36 billion parameters are used at any one given point to process any one given token. And that allows it to be much more efficient than just having a dense architecture that ends up using every single parameter to process every single token. The MOE implementation that we use is the Mega Blocks dropless MOE implementation. And we do train on the internet, but we tried to kind of filter our data set a little bit to try to make it at least somewhat usable by enterprise. And in our experience, we have kind of deployed it to some enterprise customers, and they actually like how well it works for their use cases, but it doesn't necessarily cover all of their use cases. To talk a little bit about what an MOE architecture is, generally speaking, you end up having a transformer model. So this is a representation, a block diagram representation of a transformer model. You have your embedding layer, then you have n transformer blocks or multiple transformer blocks. And then you have your unembedding layer, so takes your embeddings and converts them into tokens again. The n transformer blocks are kind of built out of two components. You have your attention block. And so that's the attention is all you need is the original transformer paper. And so you have that attention block. And then you also have a feed forward network. The feed forward network, generally speaking, it ends up being a couple of matrix multiplies, a few other element-wise operations, and then another matrix multiply. And that's generically what people use to have their feed forward network. With a mixture of experts, what you end up doing is you end up having multiple blocks like this. And so in DBRX, we ended up having 16 blocks. And then you have a router that routes every token to to only a few of the experts instead of using all 16 experts. As a result, you end up using every single token ends up using a subset of the total number of parameters. And therefore the model capacity, the model has the capacity to store information using 132 billion parameters, but you actually only process each token using 36 billion parameters. That makes sense.
Someone has to have a question after that. You quantize it down to 36, right?
It's not quantization. So the quantization is what you do to the floating point weights after the fact. This is just the sub portion, the network architecture. That's kind of the block diagrams. And when you kind of get into the details, the MOE part of the network is in the FFN, or the feed forward network, or that submodule. And what that really means is that you end up using in DBRX, we have 16 experts and we only end up using 4 experts. And so the router ends up deciding which 4 experts each token will be processed by.
How does the router decide that?
So it's again like a learned router. And so it learns how to route the data from the data. Initially, it's just randomly routing things and seeing kind of what works and what doesn't. And then over time, it learns, this router is better, or this expert is better able to process these types of data points. And so it over time learns to do that.
There's no human in the loop anywhere.
No, that would be on 12 trillion tokens, that would be impossible.
I was wondering, what do the experts actually learn?
Right. So we call them experts. That term is very much overloaded, and don't think about them as experts. They're just submodules within your neural network. And there's a lot of research that tries to kind of understand the intermediate representations of neural networks. At every single NeurIPS conference, there's going to be 2 papers about what the hidden representations try to represent. There will also be 3 papers talking about how the last conference papers about what the hidden representations represent, how those papers were complete garbage. And so it's a very much open area of research. It's often called the space of interpretability. And the real answer is we don't know. It is whatever the data tells the network that it needs to represent. And that's kind of the whole shtick of neural networks and machine learning is you don't know what the function is going to be, and the function is learned from the data. That doesn't mean that you can interpret what the learned function is, but that's kind of the idea. Yeah.
So for a practical example, let's say I put a prompt in that asks for summarization, put another prompt in that asks for, to generate a Python function.
Yeah.
You're saying the neural net doesn't really know anything about that. It's just going to take its knowledge base and kind of route it the way it's supposed to go.
So the neural network is trained using next token prediction. And in all honesty, I think something like code generation works because there's a lot of code on the internet that it learns to generate from. And so it knows that, when you have an open parenthesis, somewhere after that, there will be a closed parenthesis. And it is purely a statistical model that tries to predict the next token given the previous tokens. Now, when I say purely a statistical model, this is a relatively complex statistical model that we as humans don't know how to interpret the inner workings kind of at all. And like I mentioned, at every single conference, there's somebody that claims that they have new insight into how to interpret the inner structure, but I don't think that I've seen a really good explanation yet. Cool. Next question.
For the learning of the route, do I have to consider that as some type of reinforcement learning that runs during the pre-training?
So it's pure backprop during pre-training. Everything is pure backprop. The router backprop is a little bit sketchy-ish because it's not pure backprop. It is pure backprop, but we have to make some approximations. The reason that we have to make some approximations is at the end of the day, the router needs to learn how to route the token to, oh wow, time flies. how to route each token to 4 of 16 experts, which means that it's taking a top 4 operator. There is no differentiating a top 4 operator. And so we use the straight through estimator and say that that's going to work well enough, but does it? And it does work well enough. Is there a better? Maybe. Yeah.
Curious about it. Starting saying 4 out of 16 experts, like you mentioned. Is there a way you can make the right balance and not one single expert overload?
Yeah, so we don't want to like make hard constraints on that, but we do want to enforce some form of balanced routing. And so we do put a what we call a load balancing loss that tries to balance the load between the experts. It's a regularization term. Yeah. Yes.
For the top, like the prompts, if I did like some form of prompt engineering where I told it I want particular sources when it generates the answer, would that have an influence over which experts are used?
No. So the experts, like I mentioned earlier, they're not actual experts. That's just what we call them. The experts just kind of learn what they learned from the data. And yeah, we don't know where your token's going to get routed a priori. It's just going to be routed where the router decides. How it decides that? It's learned from the data.
How many bits of the parameters?
So training is always in full precision. It's only inference that you.
32 bits.
Yeah, 32 bits for training, almost always. We have mixed precision training where a lot of the math is done in 16 bits instead of 32, but the master copy of the weights is always 32 bits. Yeah. All right. So the architecture, so I talked about the fact that it's an MOE. Many modern models are starting to use mixtures of experts. DBRX also uses rotary positional embeddings to encode the location of each token. We use gated linear units as a sub architecture component. We use group query attention that helps with inference a little bit, or the memory that the network needs during inference. And we also use the GPT-4 tokenizer. The tokenizer is like the very first step in the network. It wasn't even drawn on my block diagram, but it's a good tokenizer and it's open source, so we just used it. So let's talk a little bit about how we built DBRX, or as I like to train, or as I like to say, how to train a DBRX. So how do we build DBRX? DBRX is built by the Mosaic Research team with contributions from many teams across Databricks and the wider AI community. Within the Mosaic Research team, we build the components that are shown here. We have our Composer team that builds Composer. It is a neural network trainer, and that helps you train neural networks, and it helps you train neural networks at massive scale. We have used it to scale training to 3,000 GPUs so far, but we don't necessarily think that that's the limit, and we will use it to scale training to probably more GPUs in the future. We also developed this library called streaming datasets, and that helps us stream our datasets from object stores instead of needing to like download everything at once. We just stream it as we need it. We build LLM Foundry, and LLM Foundry is one of the most efficient LLM training frameworks that is open source, and that's LLM Foundry is like that's what my team maintains. And we also have the evaluation gauntlet. It's a library for evaluating LLMs that we build in-house, and we have our performance team who helps make training more performant, but also does a lot of the work for making sure that inference deployments are as efficient as possible. We also work with a lot of teams across Databricks to help us train these models. For instance, earlier I mentioned the idea of clustering all the data to try to like find where the higher quality sources of data are. To do that, the tooling for that is built by a company called Lilac AI, which was more recently acquired by Databricks. So now we just put that into the Databricks team slide. We also also use Apache Spark kind of a lot. I don't know how many of you use Apache Spark, but one of our stories is that at Mosaic, we did not use Apache Spark to pre-process our data. And the MPT, the set of models, is about 1 trillion. We trained that on about 1 trillion tokens. And to pre-process the 1 trillion tokens, what we would do is we would just have like a single machine with as many cores as we could find, and we would, launch the pre-processing script. And to pre-process 1 trillion tokens, it would take about like 2 days to run. It's like doable, but extremely annoying, especially if you want to like change anything about the data set. After joining Databricks, we found all the Apache Spark gurus. We had a few of them join our team and help us out a little bit. We built a notebook to pre-process our data. This time around, we pre-processed around 4 trillion tokens, so 4 times as much data. Instead of taking 2 days to pre-process it. Anybody want to guess how long it took this time around? Less. 10 minutes. Yeah. Did I hear 10 minutes? Yeah. That's just my plug for Databricks, guys. It's awesome. You should all use it. We use Unity Catalog to store the data. We use MTC, so Mosaic Multi-Cloud Training, to distribute training across the 3,000 GPUs. We use MLflow and Lakeview to do some of our experiment tracking. And we also have the foundation model APIs and the AI playgrounds to and the AI playground is like that screen share, screen capture with like the generating. That's what I showed earlier. And we use that to kind of evaluate the models and chat with the models, red team the models. Yeah. Cool.
Good question. Who can tell me what Lakeview is? It's the dashboard tool, right? The dashboard tool?
Yeah.
Or it's the new dashboard tool within Databricks.
Yeah. Cool. Yeah.
Can you describe pre-processing of the tokens?
So pre-processing of the tokens, what we do is we pre-tokenize all of our data and we chunk all of our data, and we set it up so that during training, there is no pre-processing, because we want to make sure that we feed the really expensive GPUs, and the bottleneck is nothing to do with pre-processing the data.
Just doing all your embeddings.
Yeah.
And chunking it.
So you chunk all the data, you embed everything, or you pre-tokenize everything, and then you run it.
Where do you store the chunks?
In some version of like Unity Catalog, and we have like our
table or S3 bucket?
It is an S3 bucket, and we stream everything using the streaming datasets library to stream from an. It's not an S3 bucket. What bucket is it? It's some bucket. I think it's an OCI bucket, not a S3. But yeah.
Can you speak about the regions and how you guys handle? Like, I see the multi-cloud. I just kind of want to know a little bit more. The community tell it's sort of a single region, but
yeah,
distributed. And I'm just curious, what the strategy is there?
Yeah. So when you train neural networks, you almost always want to make sure that all of your GPUs are in one place. Moving data while doing the compute between the compute is really hard to do, and like nobody really knows how to do that. So all of your GPUs have to be in one place. And then as far as like where the data is stored and where you write your checkpoints to, you checkpoint your model to, we try to create composer and streaming data sets in LLM Foundry such that the regions don't matter at all. And so part of like the streaming data set library, like our whole thing is we don't want to, when we launch the run, we don't want to need to download all the data all at once and then start actually training. What we do instead is we only download the bits of data that we need for like this next or this step plus like the next like 100 or something. So we pre-download a lot, so like 100 steps or something. But we don't want to like download literally the whole data set, just the chunks that we need. As a result, like wherever the compute is, whatever region it's in. We don't care where the data is stored. And we also don't care where you're writing like your checkpoints to or reading them from as well. Yeah, we kind of designed the system to be effectively cloud agnostic. And that in effect allows us to like kind of maybe get cloud providers to compete for our business when we rent GPUs, not necessarily us like being forced into one cloud provider.
Yeah, I'm not Databricks specific, but when you're training massive models, is there like a competitive nature to those resources? Like is in or have we gotten to a place where if 4 more companies at this site added data, that no one would be competing for, hey, I'm trying to use 4,000 over here. Like, is there any issues or?
So that's on the cloud providers end and a little also on like NVIDIA side. Like different organizations build their own clouds differently kind of thing. Databricks, we don't want to like manage the compute ourselves. And so we mostly like subcontract compute most of the time. Granted, places like Meta, so they released Llama that I talked about a little bit earlier. Meta built a data center with like 350,000 H100 GPUs. That's a lot of GPUs, by the way. And so like different companies are building data centers like pretty much as quickly as NVIDIA will sell them H100s. And so we don't necessarily compete with places like Meta because they have their own. Google has their own compute. Yeah. And I think that there is like this lore that training something like GPT-3 was this massive undertaking that consumed like half the world's compute or something. We did this on 3,000 GPUs. Meta has 35,000 GPUs, 3,000 versus 35,000. Like we are nowhere near saturating the capacity of what NVIDIA can put out there. And kind of like our message behind, or yeah, part of our message is a lot of people can do this. It's not that hard. And if you don't know how to do it, like Databricks kind of, we open source a lot of the tooling for how to do this and we'll help you if you need. Right. So yeah, we use these tools from, these are some of the teams that support us from Databricks. And we also worked in collaboration with other organizations, including Stanford. We use PyTorch under the hood. NVIDIA GPUs are used, and we use NVIDIA's TRT LLM library to serve the models. We also use a VLLM as another serving tool for the models. We worked with Luther to evaluate the models, and we work with AI2 as well to maybe do a little bit of evaluation, but also they helped us with some of the data. And at the end of the day, like Databricks, we can kind of do it all, and we help our customers do it all when it comes to LLM training. Anything from like ingesting the data to pre-processing it to analyzing the data, and then pre-training your LLM, fine-tuning your LLM, making your LLM do RAG. Databricks has kind of become a one-stop shop for doing all of that, and DBRX was kind of the proof in the pudding. Cool. So let's talk a little bit about how well the model did. So we evaluated the model using multiple kind of evaluation sources. So one of them was the Hugging Face Open LLM leaderboard that has a couple of subcategories. And we also have the Databricks LLM Gauntlet, which is an open source, or which is a benchmark that we've open sourced. Under the hood, the LLM Gauntlet is actually another 30 open source benchmarks that we end up kind of grouping into 5 or 6 subcategories to help kind of us understand what the model is or is not learning. Overall, the performance of DBRX, when it was released, it was the best open source model out there. On the OpenLLM leaderboard, it outperformed, every other open source model, and on the Gauntlet composite score, it also outperformed every other open source model. For the OpenLLM leaderboard scores, if you break it down a little bit, you could see that DBRX outperformed all other models on language understanding, which a lot of people use MMLU to measure that. We also did really well on common sense reasoning compared to other models. And HelloSwag is how people measure that. A caveat on these figures, you can't really see much of a dynamic range there. HelloSwag, I think like a random model getting random chance ends up landing somewhere here. So like this is the true zero, you would argue. And yeah, that would be a lot more representative of the dynamic range, but I had these figures made, so it didn't communicate that well. Yeah, anyways, moving on. Human eval is how we measure the model's ability to code. And DBRX does really well, even though we weren't necessarily building a coding model, where something like Llama on its own does really poorly. Llama, they took it and they tried to make it a coding model exclusively. So like their whole target was making it better at code. And it began to do a lot better, but DBRX is still even better than the code Llama 70 billion parameter model. And this kind of also demonstrates the fact that when it comes to Databricks customers wanting to deploy models for doing very specific things, this is kind of the gap that you kind of see from deploying or from training your model for doing a specific thing versus just training a generic model. Granted, we trained a really big, really good generic model, but if you want it to be very good at your specific task, this is kind of the lift that many times people will see for fine-tuning the model on their own data for their own specific tasks.
Was it your work to make sure that the pre-training data is not polluted with any of these benchmarks?
Polluted with these benchmarks specifically? That's a good question. I don't think we explicitly checked for that. So we used an open source data set and then did a little bit of filtering to like get rid of PII and some other things. But yeah, the open source data set, like when it was released, they said that they didn't have contamination from evaluation. So we didn't necessarily check for that. So we were talking about, yeah.
What made the, I guess it's score higher. So I'm sure it first wasn't at like 70%, it was at 40 or 50%.
Or what?
Like if you first started training it or when you were developing it.
Yeah.
What increased the score so much?
Just more training. We didn't like necessarily target DBRX to be a specific type of model. We were just creating a generic model trained from internet data. Now, internet data has a lot in there. For instance, there's a lot of code, there's a lot of math in there. And so as training goes on, the models gets better and better for time.
So you didn't change the architecture, you just kept pumping in more often.
That is, yeah. There's a joke within the ML community that scale is all you need. And so just scaling up the amount of tokens that you pump into the model is kind of the approach. Cool. The last benchmark that I want to kind of show for comparing against open source models is GSM-8K. It is a math data set or math eval. And so you're just trying to make the model solve math problems. Again, DBRX is pretty good compared to other open source models. This table kind of summarizes a lot of them. In general, the gist is that DBRX is probably the leading open source model at the time of release. We also compare the model to closed source models. So closed source models are kind of the models that companies invest so much money into that they'll never kind of release them. That includes your GPT-4, Gemini from Google, I don't know, maybe some others, but yeah, we'll kind of go through them. So GPT 3.5 is the original model that ChatGPT was powered by. And you can see that on the MMLU or the benchmarks that we just kind of looked at previously, DBRX beats GPT 3.5 on all those benchmarks. There's also the Gemini Pro model from Google, and you can see that while Gemini Pro is slightly better at math, at the other evals that we measured against, DBRX is slightly better than Gemini Pro. And so in general, we say that we're relatively competitive with Gemini Pro. And this is a closed source model, so we don't actually like know the details of what they did. And then we also compare it to another model called Mistral Medium. Yes.
Especially with math, not related. What math do you tested on? You know, like your grade level?
So that would be like if you the specifics of the evals, I would recommend that people like go and read. So most evals have an associated paper that people release with them, and so you can go and read about the details there. I have not memorized every paper from every eval. Yeah, at the end of this project, we had like effectively like 2 people per eval, and they were trying to like run these evals and run the eval on our model and also run eval on the competitive models. So there's a lot of work that goes into just running the evals. Yeah, so this is another model. I don't know if you guys know what Mistral is. They also have models they release, and our model is competitive to it. This is a table that kind of summarizes a lot of it. Something like GPT-4 or Cloud Opus is the best model, closed source model out there. And while we don't necessarily beat those models, we are competitive with a lot of other closed source models that exist out there. We also evaluated the model on long context tasks. That also includes RAG style tasks. And we can see that on something like KV pairs and also Hotpot QA, DBRX, we are worse than GPT-4, we'll admit that. But we are better than GPT 3.5, and we're also better than like the Mistral model that we compared to. For RAG specifically, we tested benchmarks on natural question answering and also Hotpot QA. Again, GPT-4 is the best. Is a very good model, but our model is better than, again, GPT 3.5, the Llama models, and Mistral. Yeah, I'm going to fast forward a little bit. So I'm going to talk a little bit about the training efficiency and why we chose the architecture we chose, and how some of our data cleaning helped us improve training model efficiency. So we see that before releasing DBRX, we also trained a couple of smaller models internally, and we call those like MOE-A and MOE-B. MOE-A was somewhat similar in size to the MPT-7B model that Mosaic had released previously. And what you can see is that for a similar amount of training, the DBRX architecture and data approach is almost 4 times better than the MPT model. So how do we get to this 4x? Here in this subset of the table, we try to compare the MPT model versus the advanced version of the DBRX. And so what we're really doing here is we're not really comparing the model architecture difference. What we're comparing is the change of the tokenizer and the data set. And we see that for the same number of tokens, when we train on the same number of tokens, the DBRX version gets much better performance than our MPT models. Okay. And also when we train that DBRX data and tokenization using half of the tokens, we see that the scores are relatively competitive to one another. And so from our perspective, we get about a 2x win from just having better data and better tokenization. That's kind of what this slide says as well. It's 2x better data. We also, using better data, so we compare ourselves to something like Llama. And compared to Llama 13B, we ended up using about half as many flops to train the model. And we see that the MOE architecture using half as many flops ends up being slightly better than Llama 13B. So from our perspective, that was kind of the signal that the MOE architecture gives us about a 2x win. So in aggregate, going from our old architecture and our old data to, or our old data cleaning tools and our methodology for gathering data, and taking it to the new methodology for gathering data and the new architecture, we end up getting about a 4x win for training. Yeah.
How does this impact fine tuning?
So the fine tuning, so the architecture is still better. And so you get the 2x win from there. And then fine tuning really comes down to the data that you bring to the fine tuning.
Would you expect the same kind of performance, if I was fine tuning in this architecture versus another one?
Yeah, so you would expect kind of like a relative win of about 2x from just the architecture. And then as far as the data goes, it comes down to what data you bring to the fine tuning. Cool. Let's also talk a little bit about inference efficiency and how the architecture we chose makes inference much faster. So I'm going to bring up this slide again. In this slide, I kind of talked about how we have 132 billion parameters, but because we have the MOE architecture where we only route to a subset of the experts, we only end up doing kind of computation on a subset of the experts. That allows, more efficient processing of tokens. As a result, when we look at models and compare their inference to DBRX, we see that something like a dense model that has 132 billion parameters, when we compare that to DBRX, which has 132 billion parameters, those are these kind of two lines here, and these are different batch sizes, effectively. And we see that DBRX is about twice as fast, or an MOE architecture is about twice as fast as a dense architecture would be of similar size. No, actually, I think it's like 3 times as fast. Sorry, yeah. If you actually look at the raw number, it's almost 3 times as fast. When you compare it to something like Llama 7DB, so Llama 7DB is not quite, but almost half the size of DBRX. And you can see that even though it's half the size, DBRX is still faster than Llama 7DB. The only models that end up being as fast as DBRX is the Mixtral model. Mixtral model, in all the previous slides, I talked about how its performance is not as good as DBRX's because it is a smaller model. But because it is a smaller model, it is also faster. And so when it comes to inference, there are trade-offs of, it's going to be slower, but it's also higher quality than something like the Mixtral model.
What are the GPU requirements for inference?
The GPU requirements for inference, what it really comes down to is you got to store the weights somewhere. And then there's this nuance about storing KV caches that end up taking memory as well. But if you're going to do inference on 132 billion parameters, you need to store 132 billion parameters in memory.
You're stuck with the H100?
You're stuck with 2 H100s at least. So you effectively need 132. If you're going to do inference in FP8, you need 132 gigs of memory. An H100 has 80, so 2 H100s have 60 or 160. So the 132 fits into the 160. So yeah, the inference speed of the model is relatively good, or is very good, especially when you compare it to something like Llama 7DB. And I'll pull up the side-by-side comparison again that we had at the very beginning. We see that when you compare DBRX to something like Llama 7DB, even though DBRX is almost twice as big, you'll see it generate some code, and it generates code almost twice as fast as Llama 7DB. So 134 billion or 134 tokens per second versus, I think it was like 84. So not quite twice as fast, but like maybe 1.5. And we can talk all day about how good the model is and how academic benchmarks show that the model is good. But what we really like to see is people in the open source community starting to use the model and their feedback on the model. And there have been some, pretty surprising to us, semi-surprising kind of reactions. So this is AI2 ended up released maybe a week after we released DBRX. AI2 released a new evaluation benchmark. I actually haven't looked into this one, but what kind of surprised me is that we had no clue what this evaluation benchmark was going to be because we had no clue that it was going to be released. But then when they evaluated DBRX on this benchmark, we are the best open source model that they evaluated. So that's pretty cool. The models that are better than us, they're all closed source models. And something like, GPT-4, it's rumored that, OpenAI spent close to like 200 to 300 million training that thing, and they will probably never let anybody actually see what it is, whereas we open source the model.
The 32 billion parameters which are floats makes about 500 billion bytes.
Yeah.
Where do you store that?
So when you run training, you end up sharding your network across the GPUs that you have. So when you're training on 3,000 GPUs, if you shard that across.
For the inference, you still need all of them.
Yeah. So for inference, for training, you need everything in 32 bytes, 32 bits. When you do, so that's for training. For inference, you can quantize down to 8 relatively easily, and it'll run.
8 bits, 16 bits, how many?
8 bits.
8 bits.
Yeah, 8 bits is relatively common. People are exploring 4 bits, but yeah, 8 bits is relatively common. Yeah. And like, 16 is like the easy thing to do. And then 8 bits is relatively common these days. So that's what AI2 called Wildbench. And yeah, we were the best open source model on Wildbench. And then there's also, people that we've never met that have their own internal company benchmarks that we'll never see. But they do kind of post on Twitter sometimes. And this individual, Julia, showed that on their internal benchmarking, DBRX does very well and outperforms kind of most other models on most of the benchmarks. So how can you try DBRX? DBRX is available. You can get it through Hugging Face Spaces. You can get it through Databricks. There's also this website called u.com where you can just try it out. I'll show you guys some examples of this. This is what the Hugging Face space looks like. You could just go there and literally type in a question to DBRX and it'll respond. If you use Databricks, if your company kind of has access to it, you can go to the playground and play with the DBRX model. You can just chat with it there. There's also this company called u.com, and when you sign in, I think when I tried it, it was free. That was like a month ago. You can choose the model that you want to try to chat with, and DBRX is one of the models that you can chat with. You can also download the model itself. And there are also like versions that are quantized to 4 bits that people have been playing around with and have put out on the internet. And this is an example of someone using C++ and running the model on their MacBook. It's not as fast as running it on a GPU, obviously, but you still can get it to respond. So yeah, DBRX is an open source LLM that Databricks trained and then open sourced. It is better than any other open source model and is competitive with a lot of closed models as well. DBRX is a fine-grained mixture of experts architecture. It has 132 billion parameters total, and 36 billion parameters are used at any one point. The MOE architecture has 16 experts, and we select the top 4 to route tokens to. It is built by the Databricks, the Mosaic org within Databricks, and with help from a lot of people within the Databricks organization as a whole. And we had some help from the AI community as well. DBRX is very efficient for training because of the architecture we chose and the data tooling that we had. It is very good at inference because of the architecture that we chose as well. And it is integrated into some of our Gen AI products at Databricks as well. Yeah, any questions?
It's kind of dumb, but if Databricks or DBRX is so competitive, even with closed source models, then why make them closed?
So our kind of goal was to show our customers that training models like this doesn't cost $200 million. I have no clue how OpenAI spent that much money to produce GPT-4. Like it shouldn't cost that much. And we want to create tooling to enable companies to train their own versions on their data sets for their use cases. Because realistically, if the world is going to be transformed by AI, it's not going to be done by one massive monolithic model that nobody knows what's inside of it. It's going to be done through a community of organizations, all training their own models, all applying these models to their use cases in their like respective spaces.
So for anyone that was ever meet up like the week this came out and asked me that question, that's a better answer.
Sure. Yeah.
So how is Databricks planning to operationalize DBRX? Like, are you going to create the system that maybe give tools involved, like?
Yeah. So internally, we're gonna like more and more fine tune the model and try to train the model to be better at the things that we at Databricks needed to be better for. Like I said, we trained the model on the internet. We didn't like train the model to be specifically good at doing things that Databricks needs it to be good at. And so now we're starting to do that, and we're going to integrate it into more and more products. So like earlier, I told the story of how the Google I/O, they showed how they started integrating Gemini into like their entire G Suite of products. We're going to do that over time as well. I mean, our research team isn't as big as Google's team, so it's going to take us a little bit longer to kind of make it all happen, but we're going to do that. And and the real goal is to kind of learn how to do that more and more to enable our customers to do that more and more, to enable like AI to kind of take over like a lot of the mundane tasks that nobody wants to do, like make calendar events better.
So Vitaliy, does that mean you take the general model that's open source and fine tune it for different purposes, or is it something different?
So there's nuance to that. So fine tuning, generally speaking, I guess it's a nuanced researchy question. That's definitely outside the scope here, but like it really comes down to like the better you want to make your model, the better you want to make your model at doing XYZ, the more examples of doing XYZ you want to show the model. And so fine tuning usually implies that you end up, pumping in a couple hundred samples. And you might make the model a little bit better at doing that thing with a couple hundred samples, but realistically, if you want to deploy it, you want to, kind of build up a team to gather data where it does that thing. Yeah.
Real quick follow-up, sorry. So is the idea in the future to train the models to be really good, right? Solely rely on the model, or is the idea for the model to be able to do actions with tools? Let's say instead of doing math problems with the training that it has, we did a calculator. Uses the calculation. Calculation. So what do you think is going to really happen?
I think that like or just in general, the concept of tool use by LLMs is an active area of research, not just by Databricks, but literally anyone doing LLM research in the space. And there are kind of two schools of thought. And I personally am of the school of thought that the idea of LLMs using tools will win long term, but we'll see. Yeah.
So you commented that DBRX was much cheaper to train than GPT. Like, around what kind of numbers are we talking about for the?
So DBRX, the amount of compute that we trained it on is like somewhere in the ballpark of 10-ish million. It's less than that, but it's ballpark. When GPT-4 came out, the exact quote from
Sam Altman is someone asked, did GPT-4 cost 100 million to train? And his face was like, oh, way more. So 100 million at least. When Llama 3 came out, it is rumored that Llama 3 spent 200 million on just data, on buying data. That's a rumor. I don't know how true that is, but like that's some of the ballpark numbers that like we're talking about. Is like some companies spend way too much money doing this. We don't think that you need to spend that much money, and we don't think that, we want to enable our customers to not spend that much money and train LLMs.
So I appreciate those who are like data engineers with kind of my background being here and soaking in what you can here. Any data engineering like type questions coming into this that anyone wants to throw out there and see if anyone can answer before we officially wrap and people can chat and order in and ask more questions?
On the data engineering side, like every enterprise is going to need a vector store. So how does you talk about that a little bit on how you do, if you're going to do retrieval augmented generation, you have to have a vector store.
Yeah, you can know the Databricks is vector.
Yeah.
Okay. So Databricks has one that's built into the platform that works with Delta at this point. Obviously, there's other options that can be integrated as well. You don't do as much on the RAG side. Anything else for like those who don't do RAG a lot about what would be needed that you want to share? Is that?
So I don't do that much on it. I like my team pre-trains models, so the embedding models. Like I'm gonna, a potential project that we're going to be looking at is making a better embedding model kind of thing. But the vector stores themselves, I don't. That's a lot more of an engineering involved. Not necessarily. It's that. It's not what I do necessarily.
Yeah. It's not a training problem.
Yeah, I was told just recently the streaming data set is the streaming data sets are really like from a data engineering perspective, understanding the vector database and where that fits into RAG can be a good thing for data engineers to kind of start using your skills and get into this. That's usually how I get into it. They go, hey, I can do this, and it may not be what you all want to do. Let me help. Vector database, the streaming data set's a really powerful thing. And then all that stuff, which is probably way over my head, that's more about the MPC package. Yeah.
Is streaming data set based on sparse vector streaming or is some other technology?
No, it's just confusingly named similar.
Yeah, it's not the same. It's the whole point of streaming data sets, or like why we designed it, is to train neural networks. You end up loading samples into memory, and you run those samples through the networks. You go forward, then you do backprop, and then you take an optimization step. Most of the time what people do, or before streaming data sets, what we have to do is, like when you launch training, you end up downloading the entire data set to the compute, and then you start loading samples. So then you can start training. And so what we decided to do is like instead build a tool where instead of downloading all the data, you can just like download data as you need it. So it just ends up being a lot faster to start training. And yeah, that just helps a lot.
I think one more, he called it out, but I'll call it out again for all of us, is if you can get into the AI playground within Databricks, like you can actually pull things up and chat with them and compare the results of different models. I think that's a really good way to, you're taking the kind of stuff you can do with ChatGPT and doing it with different model options side by side. From there, I can kind of threw out there ahead of time that like serving and all sorts of things that come beyond pre-training your own model, or something that Databricks is heavy into, and probably talking a lot at Data AI Summit, and it's probably the rest of the year everywhere else as well.
Yeah, I'm just curious, for some people, some of us, let's say, who entertain the idea of building your own LLMs, how much does it cost you?
Depends on who you ask. If you ask OpenAI, it's 200 million. If you ask,
use specific numbers.
Yeah, so that ends up costing around 10 million.
Plus, you have to get the staff to do it.
That is, yeah.
Right.
We have at least a few Databricks account reps in the room. If you want to talk to them about pre-training, I'm sure we're happy to talk about it.
Yeah.
And also, this is kind of like me digging for months. So basically, you just like kick it off for 3 months and then go.
No. No. So NVIDIA GPUs, the H100s, are very fast. They're also a little bit brittle. By a little bit, I mean a lot. And training crashes all the time. Someone from my team was on call throughout the entire time. And because it was my team, I was effectively on call for about 3 months. It was horrible. It wasn't that bad, but there were some nights that like you end up staying up relatively late trying to figure out which GPU broke so that you can pull that GPU, replace it with a spare that you have, and restart training.
Any other call outs from the Databricks team about what is a good takeaway for people? No pressure, just putting on the back as you
I think like one thing that I've seen working well with customers is just having this foundation model of API and having DBRX comparing against other models for your workflows, all within the same platform. So you have your data ecosystem in Databricks. It's easy to write some quick code to actually start doing interesting. I think it's a great gateway to explore things like summarization, RAG, like things very basic. So from that perspective, that works. I think it's nice to have it integrated with the platform where your data is, not jumping through hoops, integrating other tools.
And then I'll give, so other than attending the San Francisco Data AI Summit, which would be awesome if you can get your company to pay for you to go. The other thing I'll call out is they usually put like the keynotes virtual. You can just register and watch that for free. And that's usually a good way if you're at all interested in the Databricks platform or where they think these things need to head, because they're doing what they think is going to be needed by enterprises. Watch those, hear kind of the really high level, this is why this is amazing kind of stuff. I think only Reynolds will go into the super academic paper discussions about what's going on. Most people will keep it more demo and high level and very like, get you excited about stuff so kind of know what's out there. So that'd be a really good way to keep up on it. Just a few hours over 2 days to know what's up. Or watch Advancing Analytics. Simon White will probably do a recap of that, which is like 20 minutes each day or something, and he'll summarize pretty well.
This is being curious, but well, Databricks used to sell the lake house, right? The idea of the lake house.
We still do. We still do.
Flagship product. I noticed that you changed all your marketing from lake house to AI. I know it's because AI is the future, etc., right? But how does the lake house, everything that you have been selling for the past years, fit into this?
I'll give you a couple sentences that are my take on it. This is not what I thought earlier. So we went, Databricks went from Lakehouse to Data Intelligence Platform. The foundation of a data intelligence platform is still Lakehouse. We still believe in open source data that is in the cloud that doesn't lock you into a single platform. Having the ability to do like the warehouse style interactive compute that we're used to for data warehousing, do the data lake style stuff with Spark and other types of engines like Spark. And then the real thing about data intelligence is that we really need to bring this type of tooling to the data that you have in order to make it much easier for people to get value out of that data. So if I have a really fast data warehouse, that really helps me and Brad and Joy and other people who can write SQL really well. But then someone else is asking us the question, we're writing the SQL, and they can't just like do a ChatGPT style thing with their data, right? And so as you look at automatically documenting your data, automatically, or not automatically, but being able to interface with it in a much easier way. That's the idea. It's that taking the lake house is great. There's more to it that's going to be expected in the future. So I'd say that's my take on it. Even like a simple example for data engineers is, so I know there's Copilot, I know you can do GPT and like have it code for you, but like I was in the Databricks notebook, I had some stuff in Scala that I needed to do Python, so I was going to present it to someone that likes Python. So I had the Databricks assistant convert from Scala to Python. It actually did that exactly right. Then I had it make it PEP8 compatible, so that I renamed all my variables to use snake case instead of whatever, the camel case or whatever it's called. And I was like, oh, wow, that was really nice. I didn't really want to do that. And then I got to focus on the bugs I had in my code for the rest of the night instead of converting it from Scala to Python. So once it does that for me too, it tries. It will try to diagnose for you. It does give you some good guidance. It's really good at converting the code already, and I think we're going to see it be better and better about Databricks specific things, which is probably the reason why you want the Databricks assistant versus throwing it into some other fellow. No promises there. I actually don't know the roadmap for that. I just think it's going to keep getting better because I really want it to. I'm pleading with no one that it gets better. All right, I think it's probably a good time to officially wrap. Thanks again to Databricks for sponsoring. Feel free to find some of Databricks flags.